Prasad, thank you so much for joining us today.
Thank you. I appreciate the opportunity.
What role does material science have in combating the COVID-19 pandemic? And even though it is being held in the virtual space, how can meetings like this one help to find solutions?
I'm glad you asked the question because I think material science is dead center in not only in the science that involves the development of COVID vaccine, but also the delivery of it and the distribution. So if you think about the challenges that we face, we are looking to deliver, we are interested in making sure we have an effective vaccine. And there is this whole area of how do we store and ship the vaccine. I think many of our viewers may not be, or the MRS community may not be aware, but we have a COVID special symposium that we organized here in the MRS this year, is to highlight the challenges that one faces when you have to develop a therapeutic solution in a very short time. It involves many stakeholders and a diverse group of people. And a meeting like the MRS can play a very effective role in bringing this diverse community together. And what is important is to if you think about the two prominent vaccines that are out there, the Pfizer BioNTech vaccine and the Moderna vaccine, they're both what are called mRNA vaccines. So so the trick is to deliver this genetic material, which mRNA, into cells. And it's only possible because of biomaterials, because of material science. There are special polymers that have been designed. In fact, one of the people who has done a lot of pioneering work on this topic, Professor Daniel Anderson from MIT, he'll be giving the Symposium X talk later on. We're glad to have him give this talk. He and many others have developed very innovative ways to effectively deliver these molecules into cells so that the cells can process these molecules, the mRNA, and then express this protein called the spike protein, which is very characteristic of the COVID virus. And by tricking the cells to produce this, the body thinks that there is a virus and responds to it, and that's how the vaccine works. And if you did not have these polymers that were developed and the material science that went into it, you would not today be talking about the Pfizer or the Moderna vaccine. So I think that way I would say material science is very much critical to the COVID pandemic that we're facing in terms of making sure we come out of it relatively unscathed, and to make sure that future solutions that are developed, whether it be better PPE or a better delivery system, these all involve materials and primarily polymers. And other technologies that are material science technologies. So you can see that material science uniquely is kind of the bridge that brings manufacturing fundamental like materials processing, synthesis with biology, and also with the delivery of healthcare.
And lastly, today is filled with a number of live sessions from the technical symposia. What are some of the topics that you are looking forward to hearing about?
Oh gosh, there are so many. I think the time difference is going to make it a little bit tricky for me because I'm 6 hours ahead. But I think there are several topics that I think, for example, my interests are in materials in the medical field, and of course, I'm very much looking forward to hearing all the talks in that space in regenerative medicine and drug delivery, which will bring me to the topic of COVID in a bit. But of course, there are also these new emerging topics of quantum computing, which will definitely revolutionize, how we consume data and how we consume information and how we process information. We live in this big, we live in this era of what's called big data. There's so much data that's being gathered. We are hampered by how quickly we can analyze this data, and how easily we can place this analysis at the fingertips of the consumers, like the doctors, the health givers, or it could be even something related to national security, and the data analysis is everywhere. So having better computational platforms and framework to do computation is going to be very, very critical. And there are a lot of in fact a plenary speaker whom I look forward to hearing his talk from IBM is very much involved in this area of quantum computing. So I think, there are many talks, and I'm just going to go and kind of look around and see the ones that excite me. But there are like incredible programs that we put together.
Prasad, thank you so much for your time today.